I'm going to work the same problem as in the last video, except I'll use a partial fractions expansion approach. So here's our problem: y double prime plus y prime minus 6y equals to x squared minus 3x plus 7. So kind of zip through this here. The differential operator is d squared plus d minus 6 operating on y equals to x squared minus 3x plus 7. And this factor, and so our y in particular is going to be 1 over d minus 2 d plus 3 operating on x squared minus 3x plus 7. Okay, now I'm going to break up this fraction, so I'll do some work down here. 1 over d minus 2 times d plus 3. We're going to attempt to break it up into a sum of two fractions using each of these as a denominator, each of the linear factors. So a over d minus 2 plus b over d plus 3. Of course, we're going to solve for a and b here. And so first I'm going to clear the fractions, multiply by the denominator, and on the left I get 1. On the right, d minus 2 cancels, so I have a parentheses d plus 3, and then b, this cancels, parentheses d minus 2. So quickest way to do these, I think, is to do substitutions. If I let d equal to negative 3, then this becomes a 0. It cancels off the a term, so I have 1 equals to b times negative 5. So it means that b is negative 1/5. And likewise, if we let d be the other root, 2, then 1 will equal to 5 times a, and then this is 0. So solve for a is 1/5. There we go. So the deal is now we can rewrite this operator, inverse operator, as a sum of two fractions operating on q of x. And so I'm going to do that. I'm going to do some erasing and write this out somewhat more neatly. I took the 1/5 out of these two constants, put it at the front here, and it left 1, because a was 1/5, 1 over d minus 2, and then the negative sign appears here, minus 1 over d plus 3, operating on x squared minus 3x plus 7. Well, we can distribute this in a sense through here. We could take this operator operating on that separately, and this operator operating on that separately. I think what I'll do though is I'm going to do the infinite series expansions here for these two fractions and then combine terms, and so we have just one operator that's going to operate on x squared minus 3x plus 7. So that means I need to do some more erasing. I did the infinite series expansions. If you look over here, the 1 over d minus 2, but factor out a negative 1 becomes 2 minus d. Factor out this 2. I think we've done this one before, but anyway, I wouldn't like it. Factored out to 2, so it's 1 minus d over 2. So now we'll do the expansion on 1 minus d over 2, and that would be this minus 1/2 factored out, and then 1 plus first power, d over 2, plus the second power, d squared over 4. And I stop there. Now that series goes on forever following this pattern. The next term would be d cubed over 8, but I don't need it because I'm operating on a second degree polynomial, so I can stop with the second derivative because third derivatives and higher are going to be 0. And then likewise, I took the minus 1 over d plus 3, and here I just put the negative up top and reversed d plus 3. Factor the 3 out, minus 1 over 3, parentheses 1 plus d over 3. And then did this expansion, so I have the minus 1/3, the factor, and then this expansion would be 1 minus first power, d over 3, plus the second power, d squared over 9. The next term would be minus d cubed over 27, but again, we don't need a third term or higher. So, I need to add these together. And my y particular then would be 1/5. And here we've got, I'm going to go ahead and multiply these through here. I've got minus 1/2 minus d over 4 minus d squared over 8. And then minus 1/3. Then plus d over 9 minus d squared over 27. And all that operates on x squared plus 3x, I'm sorry, x squared minus 3x plus 7. Better fix that. So there's our y particular. And I think, let's go ahead and combine all these terms before we go farther. So I sure hope all this is right. This is actually my second time doing this particular video. The first time I screwed up so bad, I decided I'll just redo it. So y particular, 1/5. All right, so let's see. Minus 1/2 minus 1/3 is minus 5/6. And now the d terms, I have 1/9 minus 1/4. 1/9 minus 1/4 would be 4 minus 9 over 36. So it'd be minus 5/36. And my last fraction is going to be minus 1/8 minus 1/27 times d squared. Let me put the d here. Better remember to put the d. So basically it's a negative of 1/8 and 1/27. So 1/8 plus 1/27 would be 27 plus 8 over, what's 8 times 27? I think it's 216. Yeah, 216. Because that's 2 cubed times 3 cubed, that's 6 cubed is 216. So we have what, 35 over 216. And it was a negative, minus 35 over 216 times d squared. And all this gets to operate on x squared minus 3x plus 7. There we go. Now looking at this, if I multiply the 1/5 through here, it will cancel the factors of 5. And so I'm going to do that, but I'm also going to take out the negative sign. And so this is negative bracket 1/6 plus 1/36d plus 7 over 216 d squared. Operating on x squared minus 3x plus 7. Okay, so now what do? I'm going to factor out my 216, and let's see here. I factor out minus 1 over 216. It's like multiplying everything by 216 inside. So 216 over 6 is 36 plus 6d plus 7d squared. Operates on x squared minus 3x plus 7. Okay, well now is the moment of truth where we do this and see if we can get the answer from the last video. I have y particular is going to be negative 1 over 216, and let's see, I have 36 times this polynomial, so that's 36 x squared minus 108 x plus 7 times 36, 252 I think, 210, 252. Okay, now I have 6 times the first derivative, so this is 2x times 6 is 12x, and minus, this derivative is minus 3 times 6 is minus 18, and then this derivative is 0. The second derivative, I only have to worry about this. The second derivative of x squared is 2 2 times 7 is 14. So that's plus 14. Now just making sure I had the signs correct here. Alright, plus 14. Okay, so y particular would be minus 1 over 216, bracket 36x squared. And let's see, minus 108 plus 12 is minus 96x. And let's see, that's minus 4 plus 252 is plus 248. Alright, now we should be able to reduce that, I think. How about we factor out a 6 and continue to reduce this. A minute ago I said I was going to factor out 6, but 6 doesn't factor out at 248. But then looking at this, looks like we can factor out at least a 4. So I'll factor out 4, and that gives us 9x squared minus 4 to 96 goes 24 times, 24x, plus 4 to 248 is 62. And if I reduce this fraction, I think we'll have our answer here. Y particular would be 4 goes into 216, looks like 54 times. So minus 1 over 54 times 9x squared minus 24x plus 62. And is that the answer I got earlier? Minus 1 over 54. Oh, what a relief. Okay, I don't have to redo this video. So, there's a partial fractions approach. And if I remember correctly, I think your book talks a lot about partial fractions coming up here. So, I thought I would get ahead of it there and show you this problem by these two different methods. Which one's better? You be the judge. I don't know. But there's that one.